Hello learners, in the previous session we discussed about the instantaneous velocity, average acceleration and deceleration. Now in this session we will continue with how can we determine acceleration using position time graph and velocity time graph. We will also discuss that how we can plot the curve for acceleration time using position time and velocity time graph. So, for this first of all I will consider an example. Here let us consider the motion of a car that starts from rest at time t is equal to 0 from the origin O and picks up the speed till t is equal to 10 seconds. So, here if you look at this position time graph, along the x axis we have a time in seconds, along the y axis we have position in meters. So, here in 0 to 10 seconds you can see the position of the position is changing and it picks up the speed, as we can see the curve over here, and thereafter moves with a uniform speed till t is equal to 18 seconds. So, if we look at this in this region between t is equal to 10 to t is equal to 10 seconds, we can see a slope which is a straight line inclined to time axis. Here we can see that there is a curve which shows that the speed is increasing or the velocity is increasing. Then the brakes are applied and the car stops at t is equal to 20 seconds and x is equal to 296 meters. So, here at t is equal till t is equal to 20 seconds we are going to discuss about it, and between 18 to 20 seconds the speed or the velocity is decreasing. So, it is a case of deceleration. So, here using this graph we can see a motion of a car picking up the speed till 10 seconds, then again till between 10 to 18 seconds the velocity remains uniform or constant, and then thereafter for the next 2 seconds the speed is decreasing. So, how to calculate the velocity using this XT graph, using this position time graph? So, for this we can find out the slope at each instant. Like for example, I need to find out what is the velocity at each instant between 0 to 10 seconds. So, for that at different instants we can draw the tangent, and this using this tan theta we can find out the slope, and that slope will give us a velocity. So, we know that velocity is delta x by delta t. So, if we have a proper data, then using the proper data also we can calculate, finding out just taking the division time interval to be very small and then corresponding displacement upon time will give us the velocity at that particular instant, and using the data we can find out the velocity at different instants. And also with the help of the graph we can just draw the tangents at different points at different instants, and that tangents will give us the magnitude of the velocity. So, that is how we can plot the velocity time graph using the information of distance time graph. Now, similarly in this region when the speed or the velocity is uniform, in this region also we can draw the tangent at different points and then we can find out the velocity. Again in this region between 18 to 20 seconds we can repeat the same process and we can determine the velocities. Now, look at this, that what kind of plot do we get? Using the same information by plotting the tangents at each point, by drawing the slope at each point, we can find out the velocity at each instant, and this is the pattern we will obtain. So, here if you look at this region between 0 to 10 seconds, look at this region, just pay attention. This curve represents that the velocity is not increasing at a uniform rate. Velocity is increasing, but acceleration is not constant, it is variable, because we can see that as we are moving towards 10 seconds, at every instant we can see that the slope is getting steeper and steeper. The more steeper is the slope indicates that the speed is increasing with the faster rate. Speed is increasing with the faster rate. Now, let us find out the velocity in the region of t is equal to 10 to t is equal to 18 second, where the velocity was constant or uniform. So, for that again we repeat the process. We find out the tangent at every point or tangent at some instants, and that gives the velocity of those particular instants, and then we got the velocity to be uniform. If we look at this Vt graph, here we see that the velocity between 10 second to 18 second is a straight line parallel to time axis, which shows that velocity is uniform between this time interval. The another way is to find out the average velocity between these two instances. We drop the perpendicular from time axis of t is equal to 10 second on the graph. Similarly, we plot a perpendicular from 18 second on the graph, and at the point of intersection we drop the perpendiculars on the position axis like this, right. Now, these points of intersection we label as x1 and x2, and here on the time axis we label it as t1 and t2. So, how do we find out the average velocity in this time duration? That is, average velocity can be determined by the formula x2 minus x1 upon t2 minus t1. Now, on calculating this, what we will observe is the average velocity will be same as that of the velocity which we calculate by finding out the slope at different instants. So, this is important to notice here, that if the velocity is uniform, then the velocity at each instant by finding the slope will be same as that of the average velocity, and that is how we get a straight line parallel to time axis. So, this was in the region where the velocity is uniform. Now, let us proceed further for the next time interval of 18 to 20 second. Now, here if you look, between this region of 18 to 20 second, there is a curve in xt graph. So, again we repeat the process. At different instants we find out the slope, and that slope gives us a value of velocity at that particular instant. So, finding out the slope at different instants, we plot the graph, and finally we find that the velocity is decreasing uniformly in this region. And if we look for the time interval of 18 to 20 second, we can say that the average velocity is different as that of the velocity at different instants. So, at each instant the velocity will be different, but if we talk about the average velocity, it will be having some different value. Now, let us talk about how can we study about the acceleration using these Vt graph and xt graph. Now, let us see how can we determine acceleration using this velocity time graph. So, to find out the velocity, to use the velocity time graph for plotting the acceleration, we will study the graph in 3 stages. First, between 0 to 10 seconds, then between 10 to 18 second, and then 18 to 20 second. So, first of all, let us talk about the first time interval, that is between 0, 10, t is equal to 0 to t is equal to 10 second. So, how to find out the instantaneous acceleration? It can be calculated in the same manner as we have found instantaneous velocity. So, instantaneous acceleration is represented as dv by dt. That is, average acceleration is the rate of change of velocity, the time rate of change of velocity. So, when we take the time interval to be very small, then in very small time interval, the velocity change is also very small, and that is how we define it. We state it as instantaneous acceleration. So, in this graph, what do we do now? In this duration of 0 to 10 second, we plot the tangent at different instants, and the tangent at those particular instant gives us the information about the acceleration at that particular instant. That is, we call instantaneous acceleration. So, finding out the instantaneous acceleration at different instants, we plot the acceleration time graph. So, just look within the time duration of 0 to 10 second. Here this this plot represent the acceleration at different time. So, for example, when time is 2 second, the acceleration value will be this when we drop the perpendicular. Similarly, at t is equal to 4 second, we can find out the exact value of the acceleration by plotting the perpendiculars. So, that is how we see that the acceleration is different at each instant. And also, since we have obtained a straight line inclined to time axis, we can conclude that here the acceleration is increasing with uniform rate. Acceleration is not uniform, it is increasing with uniform rate. That is how the line is a straight line inclined to time axis. Now, let us discuss about the time duration between t is equal to 10 to t is equal to 18 second. So, again we can find out the average acceleration for this time duration. So, average acceleration will be, we just take 2 points, the initial and the final location, and then we just drop the perpendicular on the time axis, that is between 10 to 18 we are talking about, and then again plotting the perpendicular over here. What do we get? We get the change in velocity is 0. The change in velocity is 0 during this time interval between t is equal to 10 to t is equal to 18 second. So, since the velocity change is 0, so from the formula of A is equal to V2 minus V1 upon T2 minus T1, we get the value of acceleration to be 0. So, within this duration of t is equal to 10 to t is equal to 18 second, acceleration is 0. You can see this is 0 acceleration, right. Similarly, we can find out the acceleration between t is equal to 18 to t is equal to 20 second. So, for this, let us find out the instantaneous acceleration at different instants. Again, we find out the slope at different locations at different time, and then we find out the acceleration to be minus 12 meter per second square. So, it is a constant acceleration. So, now let us compare the two time durations, the acceleration during the two time duration, that is between 0 to 10 second and between 18 to 20 second. So, if you look at this pattern, what you will observe that between 0 to 10 second, acceleration is changing, so that we can say we do not have a one particular value of acceleration, that is acceleration is not uniform. So, if we find out the average acceleration for this region between 0 to 10 second, let us find out. So, the average acceleration will be between 0 to 10 second I am talking about, will be how much? It is V2, its V2 will be let us say 24 meter per second if I consider, then 24 minus its initial velocity is 0 upon time is 10 minus 0. So, we get it equal to 24 by 10, that is equal to 2.4 meter per second square. So, in this region of 0 to 10 second, what do we observe? That the average acceleration is 2.4 meter per second square. But if we actually see the graph, at every instant the acceleration is different. Acceleration is different. So, we can say that average acceleration is not same with respect to the instantaneous acceleration at different instants. Now, look at this plot between t is equal to 18 to t is equal to 20 second. What do we observe? Let us find out the average acceleration in this duration. So, yes. So, the average acceleration in this duration will be, again it is v2 minus v1, that is a final velocity minus the initial velocity. What is the final velocity in this duration? The final velocity is 0 meter per second, minus initial velocity is 24 meter per second, and the time is again 20 minus 18. So, how much we will get? We will get minus 24 divided by 2, or that will be equal to minus 12 meter per second square. So, here the acceleration is negative. Here this is an example of negative acceleration as well. Again, if we talk about in terms of the slope of the graph, the slope is also negative. And again, if we see the value over here, graphically when we find out at different instants, we found the acceleration to be same as that of the average acceleration. So, this is the basic difference which we need to understand, here, that if the graph is a curve, then average acceleration will not be same as that of the acceleration at different instants. But if the graph is a straight line inclined to time axis, then it will represent uniform acceleration. So, that we can say that the acceleration at every instant will be same as that of the average acceleration, as we can verify from this graph. It is minus 12 meter per second square graphically, and average acceleration has also the same value which we are getting. So, this is how we can plot acceleration time graph using velocity time graph. Now, as we know that acceleration can be positive, negative and 0, let us discuss these positive, negative and 0 acceleration in terms of position time graph. Now, here we can see a position time graph, and this curve represent positive acceleration. So, if the curve is in the upward direction, it represents positive acceleration in position time graph. Now, look at the another graph where the curve is downwards, where the curve in position time graph is in the downward direction. So, this curve represents negative acceleration. Now, let us talk about the another graph. Now, this is a position time graph which represents 0 acceleration. You can see here that this graph is a straight line inclined to time axis, which represent that the distance traveled is equal in equal interval of time, and which is only possible when the velocity is uniform, which in turn is only possible when the acceleration is equal to 0. Now, let us consider some velocity time graphs for the constant acceleration. So, look at this graph. It is a velocity time graph, and what does this graph represent? Here, this is a straight line graph inclined to time axis. So, how do we read this graph? If we see at time 0, there is some velocity. So, initially when we started with the 0 time, then the initial velocity is v0. With the span of time after time t, the velocity is increasing uniformly and the final velocity is v. So, it is an example of an object moving in a positive direction with a positive acceleration. So, as we discussed in the previous session, an example of a bus, right, which is moving in a positive direction with a positive acceleration. We consider the reference frame such that this rightwards is considered positive and the left direction is considered as negative. So, this is an example of an object moving in positive direction with a positive acceleration. Now, look at the another situation. Here, what does this velocity time graph represent? This is the velocity time graph for an object which is moving in positive direction. Why positive direction? Because this velocity is initially in the positive direction of the reference frame, right. So, if I just extend my reference frame towards a negative velocity, then it is simple to understand, then it is easy to understand that V naught is towards the positive side. That is why the vehicle or the car is moving in the positive direction initially, but the slope is negative. So, what does it represent? It represents that the acceleration is in the negative direction. So, an object moving in positive direction with a negative acceleration. So, how we will consider this situation as? Like this vehicle is moving in the positive direction, but since the acceleration is in the negative direction, so it is creating the decrease in speed. So, it is decreasing the speed of the vehicle because the acceleration is in the opposite direction of the motion, which is very much clear in the graph also. Initially, suppose this much is the velocity V naught, but with the time, after time t, the velocity has decreased. Why? Because the direction of acceleration is opposite to the direction of the motion. So, it is an example of deceleration. Now, look at this velocity time graph. What does it represent? At t is equal to 0, the velocity, the initial velocity, it is towards a negative direction of the velocity axis. So, that we can say that the velocity of an object is in negative direction and the acceleration is also negative, because we can see that with time the velocity is increasing in the same negative direction. So, it is an example of, again I consider a bus which is moving in the negative direction and its acceleration is also in the same direction, that is a negative direction. But this is not the case of deceleration, even if it is a negative acceleration, right. So, why? Because here the acceleration is in the direction of the motion. So, that is why it is increasing the velocity even if the acceleration is negative. So, it is an example, it is a very good example of negative acceleration, but not deceleration. Now, look at the another situation, the another VT graph where initial velocity is towards a positive. Means what? It is the motion of an object which is moving in the positive direction with negative acceleration. Why negative acceleration? Because we see that the slope is negative. Also, if we look at the different time interval, then between 0 to t1, when the time is t1, the velocity reaches to 0. So, what does it mean? It is only possible if the velocity is decreasing. If the velocity is decreasing, its magnitude is decreasing, which is only possible if it is a case of deceleration. So, initially the velocity is positive, but the acceleration is negative, that is in the opposite direction. So, we can consider now a vehicle which is initially moving in the positive direction, but its acceleration is opposite to its motion. So, that is why when at time t1 velocity becomes 0 and the motion continues. What way? After the 0 velocity, the object or the vehicle turns back, means it turns its direction. It turns its direction and then continue moving with the same negative acceleration. So, the acceleration continued to be in the same direction, the velocity has changed its direction. Initially, it was in the positive direction, but now it has turned to the negative direction as we have seen here. But now, by turning the direction of the velocity, the acceleration comes in the same direction of the velocity. By turning the direction of the velocity, both the acceleration and the velocity are in the same direction now. So that this acceleration will now increase the speed of the vehicle. So, that is how we can see the velocity is increasing in magnitude. So, these are the different examples, simple examples to study about acceleration using VT graph. Now, let us recall what we have learnt in this session. A graph of position versus time can be used to generate a graph of velocity versus time, and a graph of velocity versus time can be used to generate a graph of acceleration versus time. We do this by finding the slope of the graphs at every point. Next, we studied that the slope of displacement time is velocity and the slope of velocity versus time graph is acceleration. We also studied that average velocity, instantaneous velocity and acceleration can be obtained by analyzing these graphs. We will continue our discussion in the next session.